If you watch a sci-fi movie, artificial intelligence usually looks like a single, all-knowing entity. You give it a massive prompt, and it executes the entire project by itself. In enterprise reality, that solo agent model fails. When you ask one large language model to handle a complex, multi-step workflow, the original goal gets lost in the noise of its own intermediate steps, a problem known as context dilution. Then there is tool saturation. If you give a single agent access to every API and system in your company, the chances of it selecting the wrong tool or passing invalid arguments skyrocket. Human intelligence bypasses this by assembling teams of collaborators, where each person brings a specific skill. Effective artificial intelligence requires a similar division of labor. Scaling enterprise automation means abandoning the solitary chatbot model. Executing complex operations reliably requires a structured, multi-agent orchestration system. This diagram illustrates how Anven operates as the reasoning engine within a LangChain architecture, acting as the primary orchestrator for complex tasks. It takes the initial user request, breaks it down into verifiable logical steps, and delegates work to specialized agents through orchestration chains. By handing off these subtasks, the system enforces a strict separation of concerns. The planner stays focused on overarching strategy and process management, while lower-level agents handle narrow execution. Splitting planning from execution means the system avoids burying critical directives deep in a crowded context window, entirely bypassing the lost-in-the-middle phenomenon. Each specialized worker agent receives only the exact contextual parameters that it needs to complete its specific job. This targeted approach keeps the signal-to-noise ratio high and protects the accuracy of the overall system. Once a task is delegated, it lands with a tool operator agent. This digital worker is strictly constrained to a narrow set of permissions and is only allowed to access the specific tools required for its assigned step. These operators follow a structured execution loop known as the react pattern. The agent reasons through its specific directive, takes an action using its assigned tool, and observes the result before taking the next step. This flowchart tracks the retrieval augmented generation pipeline. When taking an action to retrieve data, the agent queries the internal vector database for precise factual information. This retrieved data is then injected directly into the prompt alongside the user's query before generating a response. Because the worker agent is bounded exclusively to the data pulled from the vector store, it relies entirely on verified internal knowledge. If the answer doesn't exist in the database, the agent reports the absence rather than fabricating a response. Even with specialized tools, autonomous execution requires oversight. The workflow utilizes a Critic agent, an entity whose sole function is to evaluate the tool operator's output against predefined business constraints. If the Critic detects an error or an anomaly in the logic, it triggers a recursive feedback loop. It forces the worker agent to pause, review the failure, and retry the step before passing any flawed data down the chain. For high-risk actions like executing a financial transaction or altering production data, the workflow stops entirely. The agent surfaces its plan and waits for explicit human approval before proceeding. Building human intervention into the architecture provides a necessary control plane that forces the system to optimize for context and consequences, turning raw autonomy into a reliable enterprise accountability. This schematic contrasts probabilistic AI with engineered deterministic execution. Instead of treating AI as an opaque cloud where you hope for the right answer, the system functions as a sovereign architecture built for precise, verifiable outputs. This diagram compares the text-only Anven 1 architecture with the multimodal Anven 1.1 model. Using a late fusion approach, the multimodal model processes visual elements and linguistic text simultaneously within a shared vector space, automatically auditing embedded diagrams alongside written LINO clauses. By leveraging highly efficient 3 billion parameter models and quantized low-rank adaptation, enterprises can embed their specific industry logic directly into the model weights. The entire agent team runs locally on private infrastructure without the overhead of massive hardware clusters. The next stage of enterprise operations relies on a sovereign, secure network of specialized digital workers, collaborating to turn your proprietary data into an absolute competitive advantage.